Today we are going to study a chapter that is magnetic effect of electric current. This chapter is there in class 10, 12 and this is there in NDA syllabus. So let's start. So the chapter's name is magnetic effect of electric current. That means there are some effects of electric current and especially today we are going to discuss about its magnetic effect. So what exactly it is stating? So according to this effect, whenever there is current in any of the circuit, any of the coil, when the current is flowing and if you place a compass needle very close to the coil, the compass needle will start deflecting, and you all know the compass needle deflects only when there is any magnet or when you place the compass needle in a magnetic field. But here we will find whenever we place a compass very close to a coil where the current is flowing, you will find this magnetic needle will deflect. This deflection in this magnetic compass shows there is a magnetic field, but there is no other magnet other than this circuit. That means we get to know that this electric current is producing the magnetic field due to which this magnetic needle is deflecting, and this effect is known as the magnetic effect of electric current. And this experiment was first demonstrated by scientist Hans Christian Ørsted, and from that day we started considering that electric current is having some magnetic effect. Means whenever, in simple words if I want to say, when current will flow in a conductor, it will behave like a magnet. It will have some magnetic property which we call as magnetic effects of electric current. This is magnetic field. So since we are studying about the magnetic effects, we should understand a very conceptual thing that is called magnetic field. So what is exactly magnetic field? If this is a magnet, surrounded by this magnet, there should be a space where magnetic effects are there. Means if you try to move into this space, you can feel the effects of magnet, and that space is called magnetic field. The space surrounded by a magnet in which we can feel the magnetic interaction, we can feel the magnetic effect, it's called magnetic field. Okay, so now this is a bare magnet. In case of a bare magnet, the magnetic fields are in this area where you can have this magnetic effect. And just to know, just to check the magnetic field, what we have to do, we can take another magnet. Whenever we'll try to move this magnet towards this magnet, once it will start reaching into the magnetic field of this magnet, the small magnet will start to feel the interaction. If this is North Pole and this is similarly North Pole, then that will feel a repulsion. And if it is North Pole and we will come closer to the South Pole, it will start attracting. So simply by bringing a magnet to another magnet, we can easily find out its magnetic field. The next topic that we are going to cover is magnetic field lines, and this is also known as magnetic lines of force. The magnetic field lines is also known as magnetic lines of force. So what is this? Just before we are discussing about magnetic field, means the space surrounded by a magnet in which we can feel the magnetic field, it's called magnetic field lines. And these magnetic field lines can be represented by these imaginary lines which is called magnetic field lines. So these are the imaginary lines which are present in the magnetic field and which can easily represent the presence of magnetic field surrounded by a magnet. So these lines are not the actual lines, these are the imaginary lines which are present inside the magnetic field, and they are called magnetic field lines, or they are also known as magnetic lines of force. Okay, so now this is the North Pole and this is the South Pole. You have seen this is a bare magnet, and in case of a bare magnet, this is the shape of magnetic field line. Topic that we want to cover, that is properties of field lines. So there are some specific properties of magnetic field lines that we are going to discuss here. The first point is here, the magnetic field lines are closed curves. Okay, the magnetic field lines are closed curves. If this is a bare magnet, this is the North Pole and this is the South Pole, The magnetic field lines are like this. They are the complete curves like this. They are not half curves. So they are the full curves like that. So that's the first point. Magnetic field lines are the closed curve. The second point is the direction of magnetic field line is from north to south. The direction of magnetic field lines are always from north pole to south pole outside the magnet. You will see in outside the magnet the direction is from north to south, and inside the magnet it is from south to north. So I can write the direction is south to north inside the magnet. So this is about the direction magnetic field line. The next important point is at any point if you want to find out the direction of magnetic field, what you have to do? You have to draw a tangent simply. At any point to know the direction of magnetic field, what you have to do? You have to draw a tangent. So tangent drawn at any point in magnetic field lines represents the direction of magnetic field. Next point is if there are magnetic lines of force, and there are a lot of lines of force, this is very crowded lines of force. If the magnetic lines of forces are very crowded, so if the magnetic lines of force are crowded, it means it is a very strong magnetic field, because a strong magnetic field will always have a lot of lines of force. So we can say if the lines of force are crowded, that means it is a strong magnetic field. And obviously vice versa, if there is very few lines of force, few numbers of lines of force, that means it is a weak magnetic field. Similarly, if the magnetic lines are parallel or they are equidistant from each other, that means it is a uniform magnetic field. So it is a uniform magnetic field. Again I am repeating, if the magnetic lines of force are parallel or equidistant from one another, that means they are representing a uniform magnetic field. So whenever the field lines are parallel and equidistant, they represent uniform magnetic field. Again I am discussing the magnetic lines of force are closed curve. They are directed from north to south outside the magnet, and they directed south to north inside the magnet. And a tangent at any point in the magnetic field, they represent the direction of magnetic field. If the magnetic lines of force are crowded, they represent a strong magnetic field. And if there are few lines of magnetic field, they represent weak magnetic field. Next, if the magnetic field lines are equidistant and parallel, they represent uniform magnetic field. So this is all about the properties of magnetic field lines. All about today's video. If you really like the video, please press the like button and share it with your friends and family, and please subscribe to my channel. I'll try to put the notes in the description below, and if you have some doubt regarding the chapter, the concept, you can put it in comment section, or you can join the group. I have given the link in the description. There you can ask your doubt. I'll try to clarify it. For today, that's all. Thank you.